Well, my name is Sergio Martinez Juste, and I work at University of Zaragoza. I'm also a middle school teacher, and I would like to present to you our study titled Diagnostic Classification Models to compare proportional reasoning of Turkish and Spanish middle school students. And it has been done in collaboration with professors Mohamed Arikan, Jose María Muñoz Escolano, and Antonio Oyer Marcem. I would like to take you through the outline of what I'm going to speak about. I will begin with the introduction and research objectives. Then I will present the conceptual framework and the research methodology. After that, I will take you through the main results. And finally, I will end with the discussion and conclusions. Okay, let's begin with the introduction and research objectives. I'm going to focus on the mathematical content associated with proportional reasoning. And I would like to highlight that one of the lines of research that can be carried out at an international level is to perform cross-national comparative studies to describe similarities and differences between educational systems. In this sense, although there are more studies focused on comparing textbooks, there are not many studies that compare a student's performance in proportional tasks. Hence, our main goal is to perform a comparative study that investigates a student's mastery of 4 core cognitive skills in proportional reasoning. And we provide a comparison at 2 levels. The first one analyzes a student's mastery in global terms, and the second one, trying to provide some interpretations of the global results, focuses on a student's performance in each item. And let me take you through the conceptual framework. Both to design the test and to analyze the student's performance in each item, we took into account some important aspects related to proportional reasoning and proportionality problems. For example, the well-known difference between ratio and rate and different semantic structures. Also, the different multiplicative structures involved. We distinguished direct, inverse, and compound structures. We also introduced different mathematical tasks as missing value problems and numerical comparison problems. We presented the information to the students using different external representations. And finally, in order to study the influence of the illusion of linearity, we designed linear and additive problems. Now, let me talk about diagnostic classification models. Typically, using unidimensional item response theory models, traditional testing methods provide a single score for a continuous estimation of examinees' overall ability of a subject, for example, mathematics. However, these methods are limited in the sense of providing diagnostic feedback on multiple dimensions of examinees' cognitive ability. Hence, in the field of educational and psychological measurement, there has been a continuously growing attention on statistical models with latent variables that allow multidimensional classification of respondents. In this way, diagnostic classification models, DCM, are a family of psychometric models that have been designed for this diagnostic assessment purpose that break mathematics down into a set of skills. I will call it attributes, and classify examinees as master or non-master of those attributes based on their response to the given items. There are 3 categories of DCM: compensatory, non-compensatory, and general. We focus on general diagnostic models that allow both compensatory and non-compensatory relationships between mastery and non-mastery of attributes in each item. In particular, in the current study, we used a log-linear cognitive diagnostic model, LCDM. LCDM include all the latent variable interaction effects. For instance, LCDM estimate the probability of an examinee's correct response for an item, taking into account the predicted log odds, this lambda in the formula, of a correct response who have or don't have mastered the attributes included in that item. In this equation, I present a two-way interaction effect, but it can naturally be extended to consider any number of attributes and multiple ways of interactions. Okay, now I want to overview the methodology used in this study. In a previous study published in 2019, Aragón developed the family of 4 core cognitive skills around proportional reasoning. You can see them in this table. After analyzing Turkish curricula and NCTM standards and receiving expert feedback. These 4 attributes are the first one, understanding the concept of ratio and determining the value of a quantity in a given ratio. The second one, recognizing directly proportional relationships and solving daily life problems involving them. The third one, recognizing inversely proportional relationships and solving daily life problems involving them. And the fourth one, recognizing non-proportional relationships and solving daily life problems involving them. After analyzing Spanish curricula, we have found out that this attribute also fits with the Spanish curricula. Then the mastery or non-mastery in each attribute produce 16 different profiles. Okay. After determining attributes, a 22-item test was designed. For each item, the Q matrix that you can see in the slide shows which attributes are required when solving each item. For instance, item 19 that you can read here in the slide, which ones of the above graphs do not depict a directly proportional relationship. That item does not require attribute 1, ratio concept, but requires attribute 2, 3, and 4, because the students have to distinguish between the graphs of directly proportional situations, inversely proportional situations, and non-proportional situations. Let me take you through the samples and collection data details. Here you can see the sample size and the number of middle schools involved. As you can see, Spanish middle school size is smaller, at least in my region, Aragón. So 7 middle schools were involved in the study, in the Spain sample. And I would like to highlight 2 differences, the students' rate and the way the students did the test. In Spain, the students complete the concepts related to the attributes in 8th grade. However, Turkish finished them a year earlier. And as you can imagine from the date, Spanish students were tested during the COVID-19 lockdown. So they did an online version of the test, and they were given 10 extra minutes in case of technical issues. After we collected the data, we analyzed the data using M+ statistical software, and we found out that the best fit model in both samples were the two-way model, as that presented in the previous formula. So let's move on the results. Firstly, we checked that all the items in both samples discriminated well between mastery and non-mastery of the required attributes. And we obtained the difficulty indices for each item in both samples that you can observe in that table. A difficulty index near to 1 means a high frequency of correct answers to that item. After that, through a Fisher exact test, we studied the existence of significant differences between difficulty indices in both samples. I have highlighted the smallest p-values in green for those items where Turkish students perform better, and in orange or something like that for those items where Spanish students perform better. Okay. After that, we estimated a number of students belonging to each attribute profile in their percentages, and they are presented for both countries in this table. As you can see, Spanish students belonged to more attribute profiles than Turkish students. On the other hand, Turkish students mostly belong to attribute profiles 0000 and 1111. These results suggest that Turkish students were most likely master or non-master of the 4 attributes. In addition, the LCDM analysis showed that in Turkish sample, an average of 37.4% of non-masters solved items correctly, presumably by guessing, whereas in the Spanish sample, an average of 34.1% of non-masters solved items correctly. Therefore, were only slightly differences among students in the 2 countries in terms of answering problems by guessing. Also, it's notable that the chi-square test confirms the existence of an association between the variables country and attribute profile. This means that the students are distributed among the profiles quite differently in each country. In the next table, mastery in each attribute is calculated, summing up those proportions related to profiles in which that attribute appears. For example, mastery in attribute 1 is computed.
Sorry, Sergio, you have 2 minutes.
Okay, I'm finishing. Okay, we have found significant differences in attribute mastery between both countries regarding attribute 1 and attribute 4. Okay, let me try to do some interpretations and discussion of the previous results to conclude the presentation. As I said before, we have found significant differences between Spanish and Turkish students' mastery of 2 attributes. In attribute 1, Spanish students' mastery proportion is significantly lower than the Turkish one. This difference is particularly clear in the light of the results of items 1, 2, and 4. For instance, here you can see item 2. These 3 items are missing value problems, and item 2 involves a part-whole situation in which, given the part-part ratio and the whole, the students were asked to determine one of the parts. This result can be understood considering the difficulty of that situations on the lack of this type of problems in Spanish textbooks. On the other hand, in attribute 4, Spanish students' mastery proportion is higher than the Turkish one. So Turkish students seem to recognize worse non-proportional relationships as that one presented in item 5. In fact, Turkish students tend to overuse directly proportional strategies in many test items, as in the answers to the inverse situation. These results coincide with what Atabas and Owner pointed out about the lack of experience of Turkish students with this type of additive situation. Finally, we have found that Spanish students had a lower performance in all the items with intramathematical context as those presented in items 11 and 13. This is a clear example of the influence of different external representations over the students' successes, and can be related to the fact that in Spain, proportional reasoning is usually taught across contextualized situations and is connected with other mathematical concepts. Okay, and that was all I wanted to speak about. Thank you for your attention. If you have any doubts or questions, I will be happy to try to answer them.